Hello, everybody. This is Johnny Gohara, and I'm here with Brian Dieters. Brian's going to be doing the actual webinar. I just wanted to introduce myself and just do a slight recap of what we have done in part one of this webinar. All right, in part one, we focused mainly on the GUI design itself. We covered custom sliders, implementing bar graphs, numeric fields, also using GemScript to do the color picker, and we went over the Amulet internal RAM variables. You can watch the webinar on YouTube. I posted the link down here. All these slides will be available afterwards, so I'll pass out the link of where you can get them. I think I'll just put it on my Dropbox account and send you guys the link to that Dropbox. But the link to this, you can look at the webinar on YouTube. It's about 45 minutes long. Okay, for this webinar, Brian's going to be starting off with talking about the Arduino library that we created. So the library itself can be found on GitHub, and there's also examples on there as well. So the reason we chose the Arduino platform to do all these examples is just because the amount of libraries for Arduino, I mean, there's just so many sensors and devices that connect to the Arduino, and all the libraries are freely available. So it makes for a really nice platform to do these demos on. This library itself, for those who are familiar with the Amulet UART communication protocol, there's a lot of opcodes to know. There's, the CRC checking to implement. But this library here abstracts all the complexity out. And Brian will get into more detail, but definitely if you're interested to see how the library is written, just go to GitHub and you can download the entire directory or clone the directory and take a look. There's quite a lot of help files available for you to refer to. And this is what the system block is going to look like, what Brian's going to demonstrate. So we have our 4-3 resistive display module connected to ESP8266 Arduino. This is an Espress wireless chip from Espress.
Espressive.
Espressive. And it's Arduino compatible. So this is connected to our display using the serial connection, and it's wirelessly going to talk to this light bulb from LIFX. LIFX makes a series of smart bulbs that connect to through wireless, connect to the internet. It has phone controls. So we'll be going through all that. So Brian's going to show you how simple it is to implement this, and just go over all the pieces that he needs to go through, and you'll see it as he does it live here. All right, so let's get started. Brian?
Alrighty. So first things first, we'll start with the library. As Johnny said, you can get it on GitHub. If you're just from the main page on GitHub, you can search for Amulet Technologies. It's under Users. You can find Amulet, and then it's only got one repository right now, the library. And the README will walk you through a few, quick things, installation, and a few where the examples are. You can clone it or download it, or whatever you do. You need to put it into your Arduino libraries folder, which is usually, let's go to mine, wherever you install your Arduino folder, in the libraries folder, and then it'll download an Amulet folder. In here there's sources, the source code, there's some extras. The extras are actually the GemStudio projects that go along with the Arduino examples here. And let's go through, let's take a look at the help. So on the in the download, you actually get a link to the help here, and it's duplicated with that same help from GitHub. And then we can actually drill down into the different classes that are available. And the main one is this Amulet LCD class. And this creates an object that has a bunch of methods that you can call. And very similar to a lot of different serial-based modules, we start with a begin function. And this just initializes the serial port on the Arduino. And then we can initialize some RAM arrays with the set, word, byte, and color pointers here. And then mostly we're going to be using the set and get bytes and words and colors to pass information between the Arduino and the Amulet. And then we've got this one function called serial event. And this is the heartbeat function. This actually asks the Arduino for any UART data that's come in since it's last been called, and processes the UART state machine. So the only bit of code that you actually need to do to use the Arduino as a slave is call the begin in the setup and set up some things, and then in your main loop, just the serial event once. And we'll go through some examples to make that look pretty easy. Let's see. Let's go over to Arduino. This is the Arduino IDE. You can find some examples that come with the Amulet serial communications library. Right in the, if you install the library, they'll be right in your file menu. This one is the example where we're reading a potentiometer. We're reading it into analog input 0, and we're placing that into a RAM location. So let's start at the top. We've got the Amulet library here, and you can include that. Let's see, it's sketch include library, and then you can scroll down to Amulet library, Amulet serial communications library, and that'll just add the line that include for you. Next, we've got this word array, and it's just a 16-bit array of a 16-bit wide variable array. This is going to store our sensor values that we're reading. I don't need one this long. I only need one of the variables for this specific example, but just to reuse this code over and over again, we just make it a wide one. We've chosen 32, that's arbitrary, as the size of this array. The actual array on the Amulet side is 256 variables. But when you're talking about all the bytes, words, 32-bit colors, and then 26-byte strings, if we added all of those into this library for you, it would take up about 8K of RAM. And we're on a lot of Arduinos, like 32K bytes of program storage, and only like 4K of RAM. So it's going to eat up way more. Most Arduinos, the smaller ones, have anyway. So we wanted it to be very customizable so that you could, only declare things for what you need. Moving on, we've got this Amulet LCD object declared, the my module, and in the setup, we're going to initialize it to the correct baud rate, and then we're just going to register that words array that we declared above with the Amulet driver. And then the other thing to note is this other serial event. If you know Arduino, you still might not be familiar with serial event. It's processed after the main loop. In a loop above this, it's just process the loop, then process the serial event. And you might, depending on the Arduino hardware, you might have multiple serial events for multiple UARTs that are available. So this is the heartbeat function that processes all of the incoming UART data from the Amulet. In our loop, very simply, we're just taking the analog value reading on analog pin 0 and slapping it into a local array at index 0. We're not talking to the Amulet at all, at least. So in this case, the Arduino is the slave. Let's look at the corresponding project in Gem Studio. This is the open. So here we've got simply a bar graph, and it's looking at this href here says UART1, so it's connected over the UART1 port. There's 2 UARTs on the board I'm using. And we're querying word 0, word index 0. And same with this, same exact href here. We're looking at word 0. So let's see, I'm going to go to my device manager. I've got a USB serial COM5. I've got my Arduino already plugged in, and it's programmed with that project. And I'm going to go to the gem player options here, and I'm already talking on COM5. So I'm actually just going to use the player to communicate with a little Arduino board, and I've got a webcam set up pointed at it. So now I can move the pot, and we're going to talk to the player directly. So in this example, let me pull away. We are polling at an update frequency of 0.2 seconds. So every 200 milliseconds, 5 times a second, we're asking the Arduino for the current sensor data. We could ask it a lot faster than that, but it might not be ready. So back to the Arduino code, what we've got here is a read and then a delay of 100 milliseconds. We don't really need the delay in there. We could just be reading constantly or going to sleep to use less power. But let's say we wanted to switch things around, and instead of having the Arduino be the slave, let's have it be the master and actually send out the command. So to do this, it's just a very quick change. Instead of Amulet, instead of setting the local array, we're going to actually call a method of the Amulet LCD object, and we're going to set the word. So it's a word because the analog read on this Arduino is, the range is from 0 to 1023, so a byte only goes to 255. So we're using a word here. But if you've got other sensors that are less precision on it, bytes are smaller and faster to transmit, just as easy. So we've got, real simply, we've got my module.setWord, and if we go back to that help, let's look at the set word. Set word, we've got the first parameter is the location, and the second parameter is the value. All right, so here I'm writing to the Amulet's internal RAM word 0 location, and the value I'm writing is the analog read value, the value returned from the analog read function. That's it. Let's go back to, oops, I need to resave the sketch because it's read only. Save as documents, sure. All right, so let's verify this works. Rebuilding. Oh, you know what? I've got to change my board back. The board I'm using right now, if you look on this is an Uno. It's some off-brand OSEP Uno. It's got some extra features on it, but it's compatible with the regular Uno board. So I just go back to board manager and select the Uno. All right, now let's do it. All right, compiling. Yeah, okay, compiled. Now I'm just going to program it in. It's uploading, done uploading. Okay, let's go back to the Amulet project. And now instead of UART, we don't want to poll because the Arduino is already writing to the Amulet. So let's use, it's writing to the internal RAM variables. So let's just internal RAM. And that same exact word 0. And then let's do the same thing on the bar graph. I'll just paste the code. All right, so now these are both looking at the internal RAM word. They're not doing any polling of the UART. There's no other page function code. It's all blank. So the only thing it's doing is looking internally for the internal variables. So I hit run, and now it's playing, and as you can see, still responding to the potentiometer. So there you can see it's pretty easy to use it in either the slave or the master mode, or even a dual master. If you want to write commands to the Arduino when, like, for example, on a button push, write a command to it, and then from the Arduino side, when you have new sensor data, push that up, live on demand without waiting for the Amulet to poll for it. It actually reduces the traffic on the UART to just, instead of polling, just do things on demand. So moving on, let me close this down. I'll leave this up. We've got here to our main example today. You scroll up. Go plug this in. What I have is let me turn this off so you guys can see it. This is a LIFX light in a little, I don't know, it's some light fixture we have for marketing to take some marketing photos with. So I'll turn the light on, give it a few seconds to connect to the Wi-Fi, and then plug in my module. This is only for power. So the Amulet display is connected to the Espressive module through the serial port, and then these are the two are just power and ground. And plug it in. And it's going to take a few seconds to boot. So in this GUI, we've got the type of LIFX bulb it is. If you can read that, it's a LIFX A19 size bulb, and I can actually click button and turn it off. Click it again, turn it on, and if I click and hold, I can actually go to change the color. And this is what we did before. In the previous webinar, we created this UI, and I'm going to walk through the code on how we did this. Very simply, just adding the code to change the color. Let's see how simple it is. I've got sliders here, whatever, we can hit done. And then also, just for funsies, I'm going to bring up the LIFX app, change the color on here, and the color on my Amulet GUI changes automatically. So we're just in a little polling loop here, requesting the data from the bulb directly. My phone here is actually talking to the cloud, and then the cloud is talking to my bulb, and then down here the Amulet module is talking to the Wi-Fi chip, which is talking to the bulb directly over our local area network, just a LAN message. So how did I do it? Let's go to LIFX demo. And there's a lot of things I did, but let's just go look at this one page. I need a prettier done button, but we'll get to that. Let's go to the page functions. So as far as the last demo is concerned, most of the code is identical. Oops. What's new is this bit of code right here. So we've got the LIFX bulb works off of internally Amulet colors are in an RGB format. So the bytes are red, blue, green, and the alpha transparency level. But internally in the LIFX bulb, it uses the HSV, the hue, saturation, and value color space. So I'm converting the current color to the HSV, and we're doing that in GemScript. And I've got the function down below. We're just taking the red, green, and blue components. There's a you can look it up on Wikipedia. That's what I did, and just implemented that exact algorithm pretty easily just off of Wikipedia. And so we're calculating the hue, saturation, and value, and then we're using these variables to write to the Arduino. So again, it's connected on UART1, and we're writing word 0, 1, 2, and 3. And the word 0 is the bulb ID. So if I had multiple bulbs in the system, I could change this byte right here and write to a different color, a different bulb in the system. The hue, then I write the hue, the saturation, and the value over to the Arduino, and then I call this new one. Even people familiar with Amulet might not be familiar with the invoke RPC method, and RPC stands for remote procedure call, which means a method on another device. So I'm actually calling an RPC of index 1 on the Arduino, and the Amulet driver, the Arduino side of it, helps you set up that very easily. So that's it for the Amulet side. Let's go take a look at the Arduino code. Okay, so the main loop, let's just concentrate on the bottom part here. We've got a setup, and we start with the begin, as we always do with the Amulet module, the Amulet LCD object. And we set up the baud rate. The default is always 115/200. And we set up our RAM arrays, and we've got a new one, RPC pointer. This RPC pointer, and go back up to the top, is an array of RPC entry objects. And this is just an object that's very easy to pass a function name to. So we can see when I register these different function names to it, I register them with the RPC index. So for example, on the one that I was in the Amulet in Gem Studio, I was calling RPC1. So that is going to be set to set color, which makes sense. That's what I was doing from that page, setting the color. So what is set color? This is actually right here. This is the definition of a function called RPC set color, and it's going to call the LIFX driver and call the set color with parameters of the hue, saturation, value, and bulb ID. And it's also got this color temperature in Kelvin that we're just hard coding for now. When you're setting colors, it doesn't really matter. When you're setting whites, that's when it comes into play. So if we happen to set white, then this comes into play for the color temperature, but we're just hard coding it for now. So whenever I send the command RPC1, it's going to call set color. And the beauty of this is, if we go back down to the main loop, the only thing that's happening is processing the UART. So this is a complete dual master system where the Arduino is waiting for a command to come down, and then processing some commands, and then sending a response based on what those commands were. For example, getting the power or the color, or discovering all the bulbs on the local area network. So that's, here you've got our Wi-Fi password there. We've got, that's pretty much the gist. So let's see, Johnny, has there been any questions or anything?
No questions.
Yeah. All right, we've got, if anybody wants me to do anything, want me to try anything, code, show you what it can do, answer any questions. Here I've got one of the features of the LIFX bulb is you can tell it how long it takes to turn on or off. So we've got a little slider down here that now this time I'll hit the button and it'll take 12 seconds to turn off. And it's slowly doing it, slowly, slowly, slowly. And now it's off. Anyway, that's it. Do you have any questions? I'll go over to the...
Nope. Thanks, Brian.